The Blue Rescue Team is on a mission to find a wire with a current strong enough to revive their friend Rotom. Magnemite has the magnet pull ability, which allows it to determine the magnetic field emanating from any object. Pikachu leads the team to a scrap metal yard, where they find a hopeful wire. Magnemite tells them that it has a radius of 5 millimeters and a magnetic field of 2 times 10 to the negative 5 Tesla clockwise when looking at the end straight on. If a current of 500 milliamps is required to revive Rotom, should the rescue team use this wire? For this problem, we will be using Ampere's law, which states that the integral of the magnetic field dotted with the length of a path that results in an enclosed region is equal to mu naught times the current inside that enclosed region. Furthermore, Ampere's law allows for simplification with nice loops. In cases like this where the loop is circular, the magnetic field is always in the direction of the path. We can thus reduce the path integral of the magnetic field to the magnitude of the magnetic field times the magnitude of the path L. And so when we rewrite the law, we get B times L equals mu naught times I enclosed. Moving on to solving this problem, we observe our wire here, which has a radius of 5 millimeters. If we look at the end of the wire, we remember that Magnemite determined that the magnetic field was clockwise. Therefore, using the right-hand rule, we can determine that the current is going into the screen in the negative z direction. We determine this by having our fingers curl in the direction of the magnetic field, and our thumb will consequently point in the direction of the current. This information isn't being directly asked of us in the question, but it's useful for the rescue team to know because now they can connect Rotom to the end of the wire going into the negative z direction, so that the current can actually reach the Pokemon. Using Ampere's law now, we know what our B, L, and mu naught are because the former two were given in the problem and the latter is a constant. So we plug those in here with our 2 times 10 to the negative 5 Tesla magnetic field, and we use the circumference of a circle for our path because the wire is circular, so we use 2 pi times the radius of 0.005 meters, and we set that all equal to our mu naught, which equals 4 pi times 10 to the negative 7 times our enclosed current. We do some basic algebra in order to isolate and solve for the enclosed current, and we find that it equals 0.5 amps. Using a unit conversion, we find that 0.5 amps equals 500 milliamps. And this is indeed enough to power up Rotom, and the rescue team should use this wire. Thanks for watching.